Welcome back. This Waec question 2022 on volumetric analysis. In this question, the question was given to me in a volumetric analysis of 24.80 centimeter cube of 0.1 mole dm³ of a mineral acid. Y. Neutralize 25.0 centimeter cube of an alkaline solution containing 5.8 grams of sodium carbonate or sodium tricarbonate 4. From the information provided, calculate the number of mole of Y, number of mole of sodium tricarbonate 4, and the mole ratio of acid to base in the analysis. When you check this question very well, you find out that the acid there was not mentioned. The acid was named to one mineral acid and is represented with Y. The base there was what was mentioned to be sodium tricarbonate 4. Then for the information given, they say calculate number of mole. Number of mole is different from what when calculating molar concentration. Is molar concentration of what? Of A. But in this question, you are given a question on how to calculate number of mole. Number of mole have its own formula. Number of mole of Y, you have to calculate it separate. The number of mole of sodium carbonate 4 or sodium tricarbonate 4, you calculate separate. Then calculate the mole ratio of acid to base in the analysis. The formula for calculate number of mole is equals to N equals to C times V. N equals to C times V. Where your C is the concentration of what? Y. Is the concentration of Y. Then your V is the volume of Y. We are calculating number of mole of Y. Number of mole of Y. Number of mole of Y. Using this formula, N is equals to C times V. We have N is equals to CV. Where your C is equals to 0.100 because molar concentration is always measured in 0.100. Molar concentration is what? 0.100, which is your molar concentration of Y, 0.100. Then where your V is measured in centimeter cube, which is your volume. The volume that is measured in centimeter cube there is 24.80 centimeter cube. Your V is equals to 24.80 centimeter cube, mole dm cube. Now you are able to what? To place those values in their respective. You are able to place those values in their respective concentration and volume. Recall the standard volume is 1000. The standard volume is 1000. You say N is equals to 0.100 times 24.80 centimeter cube all over 1000, because anything volume is measured up to 1000. That's why we are introducing the standard, which is 1000. We have N is equals to 0.100 times this one divided by this, we have 0.0248. We have 0.0248. Then this one times this, N is equals to 0.100248 mole dm³. That's the number of mole of what? Of acid, which is what? Your Y. There's another method of Bible to solve this. Another method of Bible to solve this. You can say number of mole of Y or number of mole of Y is equals to 0.100 times 24.80 all over 1000. 0.100 times 24.80 over 1000, you have something like this: 0.00248 mole dm³. Either you go with this formula or apply this other method. The B part, number of mole of sodium tricarbonate 4. The B part, which is number of mole of Na2CO3. The first you have to look at here is to calculate the molar mass of sodium tricarbonate 4. calculate the molar mass of sodium transcarbonate 4, we have 23, Na is equals to 23, C is equals to 12 according to the molar mass under the question 12, then O is equals to 16. When you have something like this, 23 times this 2, 23 times this 2 bracket plus 12 plus 16 times 3 bracket. When you calculate everything together, it will give 106. So the molar mass of sodium carbonate 4 is 106. Recall, according to the question, they say why neutralizing 25 centimeter cube of alkaline solution containing 5.8 grams of sodium transcarbonate. For you to get number of mole, you have to convert that 5.8 grams of sodium transcarbonate into molar concentration. You now say mole is equals to mass concentration of Na2CO3 all over molar mass of Na2CO3. So the mass concentration of what Na2CO3 is mole is equals to 5.80 grams, because mass is always measured in gram Dn³ all over 106. The mole will be equals to 0.0547 mole Dn³. So your molar concentration now of B of sodium transcarbonate is 0.0547. How you get your mole to be 0.457? So how you get your mole to be 0.0547? Now you have to calculate the number of mole of sodium transcarbonate. You say the centimeter cube given to you is what? 25 centimeter cube. Which is what? 25 centimeter cube. We have 25 centimeter cube times 0.0547 all over 1000. Got it for the standard volume, which is 1000. When this one times this one divided by this, you have 0.00137 mole Dn³. 0.00137 mole Dn³. You can also apply this formula. With this. When you apply this formula of N is equals to CV, you also get your answer. That is to say, your C now is 0.0547, while your B is 25 divided by 1000. When you cancel it by 0.057, you get 0.00137. The last one is the mole ratio. The last one is the mole ratio of acid to base. The mole ratio of acid to base now is the value of the number of what? The value of the number of what? Acid divided by the value of the number of what? Base. The value of the number of acid divided by the value of the number of what? Of base. You have something like this, because the value of the number of what? Y is higher than the value for the number of what? Sodium bicarbonate. Do like this. Mole ratio. Mole ratio is equals to 0.00248 equals to 0.001 equals 0.00137. Divide both sides by 0.00137. This one 0.00137. This one 0.00137. This one cancel this one 1. This one cancel this. When this one cancel this, give what? 1.8. The mole ratio of acid to base now is 2:1, because approximating to 1.8 is approximating to 2:1. I believe with this explanation, you will be able to have easy access with this question whenever you come across this question. Welcome to Easy Pass Tutorial.